And we're back. Gonna do some quick stuff with mixed expressions and complex fractions. Mixed expressions and complex fractions are a little mixed up, but not as complex as they sound. They look visually gross, but you know, we can simplify them. All right, so we are looking here at, as I eat my hair, yeah, remember mixed numbers, these are just, they're cousins that got infected with algebra. So 2 2/3, it's a mixed number, right? It's 2 wholes and 2/3. Well, when they get algebra in them, it's 2 wholes and 4 and x minus 1ths. Yeah, so that's how we write it. We do have to write it with the plus sign in between. And what we need to do is we need to turn them into rational expressions. We take something like this and we turn it back into something like this. And I'm going to show you the process of doing that. Okay, so over here, we're going to focus on just this section right here because I know these look like a big wall of text. We're just going to focus right here on this beginning part. This is the original problem. Okay, 2, remember it's over 1. You see I faintly drew it in there as well. It's 2 plus that, 2 over 1 plus 4 over x minus 1. Okay, now you need your common denominator. So our common denominator is going to be x plus 1, x minus 1. I can see x minus 1. And we have to do x minus 1 over x minus 1. So this section right here is us turning our 2 into the common denominator so we can add it, right? We're giving that to the common denominator. So x minus 1 times 1 is, of course, x minus 1. All right, so there it is. This has x minus 1 here has turned into this x minus 1 right here. Now we've taken the 2 and we need to distribute it into this expression. So it's 2x minus 2, 2x minus 2. Okay, so now this is the same. This is the same thing as 2. This is an equivalent expression to 2. Cool, right? All right, so now we have 2 plus 4 over x minus 1. We have the same denominator. Okay, same denominator, so we can keep the denominator the same. There it is, same denominator, and then we just add our like terms. You have a 2x, stays the same, right? Our 2x stays the same there. And you have a negative 2 plus a 4. Negative 2 plus 4 is positive 2. 2x plus 2 over x minus 1. And that's done, okay? So all you have to do is multiply the whole number by the denominator of its little fraction there, right? And that's nice because it's just going to be over 1, so it's just, it's only going to mess with the numerator. The denominator is just going to be the same thing. It's very easy to find a common denominator under these circumstances, right? So let's talk about this. Complex fractions. They look bonkers, I know, but they are just a crazy way to write divided by. Like, it's just a vertical way to write divided by. So hopefully people by this point know that the division sign is a fraction symbol, right? 2 over 4 is the same as 2 divided by 4, right? This is the bar in the middle. This represents a number. This represents a number. So whenever you see craziness stacked like this, you can sort of break it out into, oh, okay, it's a fraction, and it's divided by another fraction. That's all it is. Fraction divided by another fraction. It's a vertical way of writing this. Okay, and as we remember, when we divide fractions, we really are multiplying by the reciprocal. So some, students here, oh, keep, change, flip, right? Multiply by the reciprocal is the better mathematical way to say it. Change it to a multiplication sign and flip it. Okay, so let's look over this over here. It looks like a nightmare, but it's really just 8t squared over v divided by 4t over v squared. Okay, cool. In order to do that, we keep our first term over v. Oops, that's not a v. Oh, what's that? What on earth was that? Over v times, now we have v squared over 4t, and now we can cross cancel, right? The 8 and the 4 becomes a 1, 8 becomes a 2, we have the t going away, and this becomes a t to the 1, because it takes it away. The v goes and becomes a 1, and this just becomes a regular old v. Cool, what's left? We've got 2t to the first v, so 2 tv's over 1, so it's just 2 tv's. Look at that. Okay, so you just need to break it down into, like, where's the bar in the middle? Okay, here's the first fraction divided by your second fraction. Keep change, flip. All right, multiply by your reciprocal, and you're good to go. All right. You know, I always say this right before it gets a little more complicated. Here we go. Some juicy polynomials to work with. Okay. So let's start this off by saying, okay, here's the bar in the middle. So we just set this up as 2 over y plus 3 divided by 5 over y squared minus 9. Okay, and then because we want to change all fraction division into multiplication, we have 2 over y plus 3 times y squared minus 9 over 5. Okay, let's factor this. This should look familiar. It's got a subtraction sign. There's a square, a perfect square. It's a difference of squares. It's so easy to factor. So instead of that, I'm going to change this into, I'm going to cross this out, and we're going to just write the actual factored form right above it. This is the same as, square root of the first term plus square root of the second term times square root of the first term minus square root of the second term, y plus 3, y minus 3, difference of squares. Okay, now look at what we've got here. We've both got a y plus 3, so we can cancel these out. Okay, and now it's looking a little messy, so I'm going to rewrite it. Okay, we have 2 over, this has become a 1, and then this has become times y minus 3 over 5. Okay, so the denominator is 5. That's cool. And then you have 2y minus 6. And there is your answer. All right, let's look over here. Oof. Looks pretty bloody, right? Let's get down to it. This is your first fraction, okay? I'm gonna write it a little up higher so I have plenty of room. N squared plus 7n minus 18 over n squared minus 2n plus 1 divided by n squared minus 81, oh, that's my favorite thing, it's a difference of squares, over n minus 1. Cool, now we're going to break each of these up into factored pieces, and at the same time we factor, I'm also going to remember that this expression, whatever it is here on the top, is going to be times n minus 1 over this factored expression, right? That n, I flipped it because we're multiplying by the reciprocal. Okay, so here we are. Let's think about this for a second. Do our little X Games thing. We have a negative 18 and we've got a positive 7. Let's see. 2 and 9. All right, so 2 and 9, and then it's a positive 7, so the 2 is the negative 1. All right, so this expression factored is going to be n minus 2. And then this is going to be n plus 9. All right, now let's work on this one down here. Factoring this one, 1 and negative 2. Okay, multiplies to 1, so that has to be 1 times 1, but it has to be negative 2, so it's got to be negative 1 times negative 1. Ah, we have a perfect square trinomial. So underneath here, we've got n minus 1 times n minus 1. All right, and up here we've got an n minus 1. Hey, check that out. We're going to get to cancel some stuff. Over here, we know this is a difference of squares. Difference of squares, which factors into n minus 9 times n plus 9. Oh, there's so much stuff we get to do now. Look at all this canceling we get to do. Okay, so n minus 1 and n minus 1 go away. This will just be a 1 up here, not a 1 up there. And n plus 9 and n plus 9. Look at that, n plus 9 and n plus 9. And now on our numerator, we have n minus 2 left over. And in our denominator, we have n minus 1 times n minus 9. All right, nothing else to cancel. This is your answer, okay? Now, of course, if your teacher wants you to simplify that, you can FOIL it out if you need to, but I'm not gonna do it. All right, so it looks really complicated, but it's just kind of a long series of stuff you already know how to do, right? Factor stuff, keep, change, flip it. Cancel stuff, done, okay? All right, and I believe that that is the end. We shall check and see if I suddenly have a, yes, that is the sign. This is the end of this section of the video. Hopefully it was helpful. Probably could have done with a little bit more of the mixed expressions, but they're pretty straightforward. So hopefully that was a help to everybody.